The next page I want you to practice and study is page 347 from the old textbook that we used to have, the non-ebook that we had before we started using ebooks. And I particularly like this old book in the circles chapter, so I like pulling out some of those old problems for us to practice. So if you will, let's take a pause and work the first 3 problems, and then I'll come back and work those with you. Then we'll do the next 3 and so forth. But I want you to be able to think through these. Now, these problems, remember what we're talking about. It's if we have a chord in a circle. If we have a chord in a circle, and I have a radius to the chord that's perpendicular to the chord, then that radius is cutting my chord in half, and it's cutting the arc in half. So remember that. It's been a little while since we've done that because of spring break. So I want you to remember that rule, and let's work through these problems. Again, take the first 3, see if you can do them, and I'll pause, and we'll come back in just a minute and work those. Okay, on number 1, let me blow these up a little bit so we can see them a little bit more clearly. On number 1, first of all, notice the directions. These directions are significant because they tell us that O is the center of the circle. So that empowers you to have a little bit of information that you would be more comfortable knowing. Okay? My radius in my first circle is 5, but the distance from the center to a chord is 3. Now remember, guys, the distance from anything is, when we talk about distance, it's going to be the perpendicular distance. So that's one reason why we know that angle at M is perpendicular. But we have to find the entire length of XY. Well, I know that this perpendicular OM is cutting XY in half. So if I find MY, I can easily double it, and that would give me the length of XY. Again, I know some of you already can see that I've got a 3, 4, 5 triangle. If you don't have those memorized, again, it's not a have-to thing, but if you don't recognize that as a Pythagorean triple, use your Pythagorean theorem that 5 squared as the hypotenuse is on the side by itself. And then let's work this out just quickly and carefully. So x is 4, but again, my question asks for the entire xy. So if I double 4, then xy is 8. Okay, likewise, look at number 2. PQ is 24, so OM is cutting PQ in half. So I'm going to have a 12 here and a 12 here. Another right triangle. So I can use Pythagorean again, or I can use my triples. This time I'm only looking for OM. It's right there. So I can say that my 13 squared equals 12 squared plus my x squared. So OM has a value of 5. Okay? OT is 9 units long. RS is 18 units long, so it's cut in half. I've got a 9 here and a 9 here. So if you'll look at this, since this is 9 and this is 9, that means I have an isosceles right triangle, or in other words, both of those angles are 45. I can either use Pythagorean or I can use my 45, 45, 90. Okay? If I use my 45, 45, 90, then I know that all I have to do is take a leg, which is 9, and multiply it by the square root of 2, and that should be the distance of OR. If I used Pythag, then I would say 9 squared plus 9 squared equals x squared. So x is the square root of 81 times 2, and the 81 comes out as 9. That's a little scrunched in there. I hope on the bigger screen you can see that better. Either way, I'm going to get an exact answer of 9 root 2. Okay, so we're going to pause and let you work the next 3, and then I'll work those with you. Okay, let's take a break. All right, we're looking at number 4 now. Number 4, it tells me that the measure of arc ACB is 110. So I'll come across here. Well, keeps coming up with my... That's 110. All right, now since this is a right angle here, then that 110 is cut in half. It's cut into a 55-degree arc and a 55-degree arc. The question asks for angle 1. I hope you notice that angle 1 is a central angle because its vertex is the center of the circle. So since angle 1 is a central angle, it will be equal to the measure of its intercepted arc. The intercepted arc is the piece of the circle that comes between the two sides of the angle. So CB is the intercepted arc. Since CB is 55 degrees, angle 1 is 55 degrees. Okay? On number 5, we have 3 equal chords. Equal chords in the same circle divide up equal arcs. So arc AB is going to equal in measure to arc BC, which will equal in measure to arc CD. We're told that AD is 120 degrees. So since a circle has 360 degrees, let's take away the 120 degrees that I know. Okay, I'm taking this out. And the rest of the circle is divided evenly 3 ways. So if I divide up 243 ways, that's an even 80 degrees apiece. So since arc BC is one of those thirds, arc BC is 80 degrees. Similarly, on number 6, we know that we've got a right angle in there that's given to us in the drawing. So since my central angle is 90, I know that arc BD is 90 degrees. But you see how these arcs are marked congruent? Can you see those little hashes in there? CD and CB are marked congruent. So that means I need to take 90 and divide it in half. And that will tell me that arc BC is 45 and CD is 45. So arc CD there is 45 degrees. Okay, we're ready to look at the last 3 that have drawings for them. So stop the video now and work on those. And we'll come back and work those together in just a minute. Okay, let's see what we've got on number 7. Angle AOB is 60. Now, angle AOB is a central angle. AOB is 60. I think my pen has died. Let me give it a charge. I thought we were doing okay. But AOB right across there is 60 degrees. Okay, let's see if that'll go now. Yeah, we're in good shape. That's 60 degrees there. Now, we also know, loves, that AO and AB are both radii of the same circle, so they're going to be congruent to each other. That means that we've got an isosceles triangle at least. So A and B must be equal angles. Angle O is already 60. So do you see what's going on here? We've got an equilateral triangle. Equilateral triangles are also equiangular. Okay? So if I have all my inside measures are 60, that means that AO, AB, and BO are all the same length. So if AB is given to be 24, then that means the radius must also be 24. Let's look at 8. OM equals ON equals 7. So I've got two chords that are the same length or the same distance from the center of the circle. Since OM and ON are both 7, then DC and EF are both the same distance from the center of the circle. Therefore, they're going to be equal to each other. If CM is 6, that means DM is 6, making this whole chord 12. And if DC is 12, EF must also be 12, because you have two chords the same distance from the center of the circle, so they must be congruent. Okay, let me move this over just a bit and see what I want to do that. See what I'm looking at here. OM is 12. Okay. Okay. So we've got AB is 18. OM is 12. ON is 10. We have to find CD. Okay. What I think we probably need to realize, first of all, is that AB and DC are not congruent because they're not the same distance from the center of the circle. One's 12 units and one's 10 units. But up here, I can take this 18 and divide it into 2 9s. And I can use this right triangle to find the radius of the circle. So I'm going to have 12 squared plus 9 squared equals my hypotenuse squared, which is the radius. So R is 15. So that means that my radius is 15. The radius is the same throughout the entire circle. So if that radius, if OB is 15, then OC would be 15. Okay? So now I can use the Pythagorean theorem to find this missing leg. And when I double it, then I would have the CD that they have asked for. So I would now say 15 squared, since it's the hypotenuse, it goes by itself. Okay, x squared is 125, so x is going to be the square root of 125, which is, it's 25 times 5, so 5 root 5. So if I want to know CD, I need to double 5 root 5. And when I double 5 root 5, I don't distribute the 2, I just multiply these two. I have 10 root 5s. So CD should be 10 root 5. Okay, I want to look at the ones below, but I think we'll do that in another video. I think that that's enough for this particular video. So I'll just make a snapshot of those at the bottom, and we'll look at those in the next video. Okay?